Hello everyone, welcome to the Self-Dev channel. As I've said, today we're gonna have one more video regarding to Golang series, and the topic today that we're gonna talking about is the power of interface composition using Golang. Gonna be our use case? Our use case we're gonna use the HTTP client HoundTripper interface. So basically, the idea is let's create something to really understand how interface works and how powerful is the composition of those interface, right? But first, first thing first, let's try to understand what is an interface stand for. When we use interface, what's our intention, right? I think that's the main question to answer. An interface in Golang, or I think any other language, it's a behavior specification, right? So anytime that you create an interface, you basically saying like, this is the behavior that I want, or this is the behavior that I expect as a contract. So not only interface, but also functions are deterministic to specify those behaviors. So actually, whenever we have an interface and we have a specific behavior defined, we'll be able to allow others to compose those behaviors with the interface composition. So how powerful it is, what we can really create in real life. So the idea today is trying to create a CLI HTTP client to allow us to understand the power of how powerful it is and how we can compose behavior in our system and create a composable, package or whatever you're trying to solve and allow your code to grow without any issue. So let's go to the code. I might not be able to express myself clear enough in English, but I'll try my best. So here, I've just created this HTTP interface folder here. So let's start it out, right? So go mod init. We just start a new mod, right? And then we're gonna create the folder here. So let's create our HTTP client, okay? So first thing first, here we're gonna have a base client that we're going to create. So I'm just rename that to, let me zoom that in, all right? So here we're gonna have our HTTP client, not interface, but we're gonna have our concrete type implementation, okay? So basically what it does, you're gonna have a HTTP client, pointer to HTTP client, right? But whenever we initialize that, we're gonna receive as a dependency injection, we're gonna receive the first tripper implementation. So HTTP HoundTripper, all right? And basically, we're gonna return the HTTP client, and the transport is gonna be the tripper that someone is putting to us, right? So here we're gonna do, we're gonna simply create a wrapper. Let's say that our library, it's a simple wrapper. So we're gonna allow clients to make post, get, and all the HTTP methods. But here we're gonna implement only post just to put in our mind the real concept, right? So basically, we receive the URL, we receive the body, that could be anything, and then we receive all the headers. It could be a map string, right? So this is what we're building. So basically here we're gonna marshal the body, right? It will be the first thing that we're gonna do. So if there is an error, we check that error and we give it back if there is any problem. So now, I don't like to put that as a name. I prefer to use the constant from the HTTP directly. So now we do have the body, right? Now we're gonna set all the headers. So basically now if the client give you a header, we just like iterate of those headers and make sure that we're going to apply those. But as we have a post request, I'm gonna do such a thing. We were gonna have a default header that always gonna be set, and that one is the content type application JSON. All right, just to make sure that we cannot. All right, and then we're gonna do CLI.do, right? So simple library, no big issue, no big deal. We don't have much thing here. So now we're gonna start creating our composition process of on top of this round trip interface. So let's say that we're gonna create a login, right? A login, um, login request. We're gonna simply do, oh, let me see here. So we're gonna simply do a round trip interface, right? And then we're gonna have a new here allowing someone to initialize, right? And tripper, and here we're gonna implement the round tripper interface, right? So the round tripper interface, for those that may know, does not know, it's simply one method interface. It's well known as a tiny interface. So basically what happens, whoever implements that internally, there is a chain of execution on top of that. So basically every HTTP client gonna call at the end of the day the round tripper interface to specify the execution on the HTTP flow. So whenever we compose that, we're gonna create a chain of those calls and we're gonna be able to um, customize or create any behavior that we want throughout the request process. Okay. So what we're gonna do here, basically what we want to do in this logging request is like, we just wanna simply log every request that we do. So here we would end up doing this, right? We're gonna call the tripper given and passing the request, but before calling it, we're gonna log it. So here we're gonna have a slog logger. I'm using Golang 122, okay? Just to make sure that you guys are follow up with me. So here I got a log. I'm gonna do slog JSON os stdout new. So basically I'm creating a log of a JSON type handler, putting on stdout, and I have no options given. We don't need that for this, the sake of that tutorial. So here I'm doing the request information, right? And here we're gonna grab the context from the request. This is good because on the propagation cancellation purpose of context, we'll be able to handle that in our info log. Whenever we are writing something, we'll be able to cancel that. So here we're gonna have the details of that, and let's log some information about this. So let's create the request log value, right? You're gonna receive a request. I'm not sure what you're trying to do, but we're gonna return the slog value from slog package, and then we're gonna return the group value. What we're gonna do here, it's like methods. We're gonna grab the methods. We're gonna grab the URL, and we're gonna grab the headers. So header, I think it's any header, heck header, right? Let's do this. It's simple like that, okay? We don't want to put so much on that. So, okay, basically, that's it. That's our logging. So let's say now that we want to, create custom headers. So we have a specification, which is, every request we need to create the X request ID, the correlation ID, these are very common things that a big system or whatever you're building for tracing. It's always good to have those kind of things. So let's say that we have that. Um, we're gonna end up doing the same thing here because we don't have much thing different from what we've been doing so far. All right. So this is our the custom hash. So let's say that every time that we return that we okay. So every time that we have a request, we're gonna perform two new headers. The first one will be uh, request ID, right? And the second one will be correlation ID. Okay. So the difference is that one we're gonna use for the Pontens case. Is that how we write this? I think it's that one. The Pontens case, yes. And here it's just like for any request, you're gonna generate a new one. So to generate that, we're gonna use the Google UID library. All right. So basically here we're gonna use a straightforward process, which will be we're gonna header set x request ID, right? And we're gonna do UID new string, straightforward, no big deal. But for other case, we're gonna do something different. We're gonna we're gonna create a hash based on the body. I don't know. Let's grab like the method, HTTP method, the URL, and the body, maybe the headers, and we're gonna create a hash from that and generate um, correlation ID based on these things. So if someone repeat this request, we're gonna be able to catch up. It's the same. So let's say that first of all, we need to read the body, right? I think that's our first thing. Now that we have read the body, if that fails, we gotta return error, right? But if we read the body in Golang, we need to make sure that we put that body back in the request. Otherwise, someone that reading sequentially will receive an EOF error, probably the handler or so someone that is trying to read the body. So we need to make sure that we gotta put back that body. So IO, I think it's not closer. Yes, and then we put back the data. What did he receive? Oh, the reader. I think it's by new buffer data. All right, so we're putting back that. So here we have the hash. Let's say that we want to create this, and this is gonna be, as I said. Oh, sorry, we used to use FMNT here. So here we're gonna put the URL string, hack methods, and then the string of that data, right? Oh, it's printf here. So we put that down. We put the headers on that. So we won't put the headers because as we are creating a new request ID, this will be different. So the hash will change. So here I'm just keeping it as it is. All right. So now we got the hashed data here. It is what this, yes, the byte itself. And then we have this encode to string hash data, right? So now we're gonna create the hack headers, set x correlation ID, and we could do such a thing like this. Just grab the first 10. I don't want to limit that. Let's keep that way. All right. I won't do. So basically this is gonna be our second implementation. third third implementation. Yeah. So now let's create two new concepts here. The first concept will be the retry concept. Okay. What is the retry? So let's say that we want to create the capability in our library that if a request fail, we want to retry that automatically. And so let's let's implement that behavior. So retry request struct, as we already know, this will all be different from what we have been doing so far. So okay, all right, thanks. Uh, Now, for that purpose, I'm gonna use the backoff library, not the backoff, sorry, the backoff library. Yeah, the backoff library. Is that the one that we're gonna use? So here we have exponential backoff. I will call as BC, right? So every time that we instantiate that, we're gonna create a BC. It's a backoff, new exponential backoff, and then we're gonna define some options patterns that they have. The initial interval between the backoff is going to be time milliseconds. So basically, we're gonna wait for 100 milliseconds to try it again, right? And the max interval will be 1 second, right? And we won't retry anything um, greater than 5 seconds. So if something happens, we would, spend 5 seconds in total to retry the request. And we're gonna uh, have a backoff window between 100 milliseconds and 1 second. So that's gonna be our simple configuration, right? So on this library, particularly, I really like this one. We have this retry function that we receive these anonymous functions, which is the behavior, and then we pass the backoff specification that we have created. So here internally, we're gonna do the trip, round trip request. We're gonna receive the response, right? We have to do RESP HTTP here in near because we're gonna reuse as we have this scope is a shared scope here. We execute that inside this stack function memory access, so we have access for that. Oh, sorry. So we can create these variables. They're gonna be that one. So basically, our point is if it is an error, we're gonna return an error, right? But also we want to return an error if the status code of that function it's greater or equal than status internal server error, right? And then we're gonna return fmt error you know, http status code status tags has status code. So that's gonna be, I think he's complaining by the capitalize here. Okay, so now we're gonna return new, right? So here's the error, and here we're gonna see return RESP and the error, right? I think we could do this whenever he try. Yes, yes. So a simple implementation, right? And now we're gonna have our last but not least patterns. It's the circuit breaker, right? I don't know how familiar you guys are with the circuit break patterns, but let's say that the circuit breaker is basically when you're trying to when you have multiple environment service and you have a lot of requests, internal requests, service to service, or you're integrating with any requests or any service outside. The circuit break patterns will guarantee that somehow your application that it's responsible for interacting with other servers will not be affected by not well behavior uh, moment from the other service. So let's say that service A gonna send a request to service B, but service B for somehow it's in trouble in that moment. A lot of requests, it's like taking too much time to respond, or it's down for any reason. If you don't have a circuit breaker implementation, the service A will start to buffering a lot of requests because he tried the request, he's waiting for that answer. So let's say that now he receive another request that he go to this service B again, and he's waiting for that answer. If you don't have like a specific timeout, or very not a very short timeout to execute this function, he wait until identify that there's a problem. And this pressure go to your service A as well as go to your service B. So the circuit breaker comes as a blocking. You start to blocking the request, so you give it time to the service B to get back, and then you're not waiting for that request anymore, because once you try to go, there is a wall, and then you go back and say, oh, there's an error, right? So that's the purpose of circuit breaker. Just um, so let's say that now we're gonna implement that. What's gonna be the library that we're gonna use? We're gonna use the Sony library, Go Breaker. It's one of my favorite, to be honest. And here we're gonna have the Go Breaker, circuit breaker, right? Is a pointer to that. And so circuit breaker, Go Breaker, new circuit breaker, right? And then the Go Breaker has settings. So let's define the settings of that. So first is the name. So let's allow the client specify a circuit name, right? So because this is why this is important, because you may have circuit breaker for different applications. So we have the circuit breaker for application B, circuit breaker to application C. It's very important to do these kind of things, otherwise you're gonna share the same circuit breaker to all, so we're gonna end up have a bug, right? Because if the service B goes down, you open the circuit breaker to all the requests that are sharing the same circuit breaker instance, which is not what we want, right? So we're gonna specify a timeout here, let's say 5 seconds. And then there is two main things here that I want to do for the sake of this tutorial. The first one, we're gonna receive this as a callback. Every time the state change, there is three states on circuit breaker. The open state, so all the requests are blocks. Half open states, partially block, so he opens up a window to see if the service has come back somehow. If not, he goes back to the open state. Otherwise, he close the circuit break, and we have all the requests free to go once again, right? So let me close that. So what we're gonna do here, we're gonna log, okay? So internally, I don't want to share any previous log created, so let's just, for the sake of simplicity, create a new one here, right? So here we're gonna log the circuit breaker, circuit break state change, right? So let's go to the details right here, and we're gonna do the same thing that we have done on the logging process, right? Just to um, be able to log this. Log values, we're gonna receive the name, um, let's say name, the name, and details, right? So we're gonna receive from to Go Breaker state, gonna return the value, this slog value. So slog group value, right? String from from string, and we're gonna have a to string. So from to, right? So we're gonna log that, and the other one is just like the ready to trip is the threshold. So how's gonna be the threshold to define if we are ready to open the circuit breaker or not? So you can define a threshold. So let's say after, oh, sorry guys, I changed that here. Hold on, circuit breaker. So basically we are saying that, let me close, zoom that in. So basically what we do here, like after 3 consecutive failures, you open the, the circuit breaker. So now we have all the, the, the definition here. So let's implement the interface. So now we're gonna do almost the same thing that we did on the retry, right? The circuit breaker has an execute function, right? So basically now you're gonna be able to do cb, tripper, round trip, rec, rasp, and error. If there is an error, we're gonna return an error, right? But if the status code of that's greater than http status internal 7 error, we're gonna return, let's say, that, and then we have a new with, and then we have a rasp and new, right? The error, if error, we're gonna return new. We are doing this just to avoid us here to panic, because here we're gonna cast directly to HTTP response because we know it's an HTTP response. All right then, so now we got everything that we want, right? So let's test that, right? So here we're gonna create a test for this function. So okay, so let's create that. So we have our, let's begin our test implementation, right? So first thing first, we should request without any problem, right? Use our basic library that we have created. So what we're gonna do here, we're gonna use the new server from HTTP test, right? Handle func, I think it's handler func. All right, we're gonna return a server, and here we just close the servers. So here, let's create some things here to be shared throughout our test. So here gonna have a raw body value will be like a map string any, let's say that, and then we have like, I don't know, first name would be like Frank, and then email will be like frank email.com, right? So this is our raw value here. So here we're gonna do something. We're gonna write header set content type application JSON, that's okay, and then we're gonna return to the client let's say raw response value here. It's a map string any. It's like I don't know, let's say the ID, status, create. I know, we don't care, right? So let's do this. So this is our basic one right now. So now let's call our package new HTTP client. And what we're gonna do, we're gonna simply give the default transport implementation, right? And we're gonna call the post here. The first method is the context. The second one is the URL. Now we have the body. The body will be the raw body value. And then we won't provide any custom headers for now. So we have the response and the error, right? What we want to do here, so let's do our assertion response func here, which receive the testing, receive the expected value, any, and the response, HTTP response, right? So the first thing that we're gonna do, we're gonna make sure that we close the body to avoid leaks, just to follow up the standards. And what we're gonna do, it's like we have a body any here. We're gonna make sure that we're gonna decode that for body. We're gonna use the require no air. I think we don't have the testify here, so I need to include the testify. That's fine. So testify from stretch. So now we're gonna do no error, all right, to make sure that we don't have error at all. And then we have a equal, the expected body should be equal to the body that we convert, right? So here we're gonna do like require no error and then assert that. So the simple test that if we run, okay, he's complaining about command. Is that what he's complaining about? So let's see if it works. All right, so good, right? So let's start out our composition process. So now we're gonna copy that, and then we're gonna include logging, right? Log composition. So we're gonna came over here and we're gonna do HTTP client new login request and then simple like that, right? If we run that, we're gonna end up having the same result, but now we have a login line, the request information, details, the post, URL, and the headers specified, right? So let's go for another composition. Now we're gonna include all the headers, custom headers, right? We include both logging and custom headers composition, right? What happened now if I simply come over here and do this? You guys gonna see that we don't have anything that has changed. Why? Because once we create that, we create the chain, right? As I said, there is a chain of execution. So what is happening is I'm logging first because my round tripper implementation from logging, it's been calling first than the custom headers. So I'm not able to see all the headers that was created to every request because I have logged before that. So what we're gonna do here is like we're gonna change. We're gonna call that and then we're gonna log, right? So this will end up have this effect here. Now we have the correlation ID and then we have the request ID, right? For every request. So let's now do the circuit breaker one, right? Um, circuit breaker. So now that we are creating custom headers, we are logging, and now we gonna include the circuit breaker mechanism. So we're gonna create the self dev composition, and then this. All right. So what we're gonna do here, we're gonna do a few chains here. So we're gonna receive a CLI. This is gonna be CLI dot rasp air. So basically now I'm going to do a for loop here of 10. We're gonna ignore and we're gonna do an assert just to avoid breaking, right? Because the required will stop to iterate, but the assert we will execute them all. So we're gonna do a few chains here. Now we're gonna do service unavailable, all right? And the response will be a map string status http status tags, the http service unavailable. Let's return service unavailable here, right? So now what we're going to see, is the behavior that we has expected, which is we log it, right? Every request, as you guys may see. And now I'm seeing the failure from the server. So basically the service returned unavailable, right? 503, 503, 503, 503. But now I have circuit break is open. So what's actually happening here right now, I'm not requesting anymore the service. And from that moment on, I just hitting that wall, blocking the request until this check of the service that is doing, in another routine, realize that the service it's maybe healthy again to receive the traffic, right? And now we're gonna implement the retry mechanism, right? Last but not least, include security blanket plus retry mechanism, right? As I said, I cannot have the retry after the circuit break is open because I'm gonna retry on top of the blocking wall already, right? So as that chain that we already know, I need to retry first, and then I create that, right? Now, if I run the same test, we're gonna see a different behavior, which is right. We're gonna see that we are not only retrying, but we have a different state right here happening, which is the half open state, because inside the threshold testing, whenever I try, I'm giving up in space to allow the library to open some requests to see if the server is okay to go forward or not. So basically now we are seeing, as we log all the state chains, we are seeing these half opens in our log, right? So this is how powerful it is whenever you implement composition on using interface, especially in Golang. So you can create powerful tools. And of course, it's always good to have in mind that this composition only happens because this interface is totally composable, right? If we would have interface with 10 methods, it will be very hard to compose our interface. I would say almost impossible to compose an interface with 10 methods because there is so much behaviors to be applied, to be fulfilled, that it's hard, right? So be in mind that every time that you're going to create any package or anything that you want to develop, put in mind that you need to create time interface, segregate interface as much as possible. And if you guys would like to know would like to know more about interface segregation, please just let us know because we can create a video about that. But just, do a homework, take a look on the IO reader, IO writer, read and close interface. They are very good examples from the core library, how they have segregations and how powerful that become to compose behaviors whenever you handle with files or things like that. All right. So that's it, guys. Thanks once again and see you next time.